Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad SYAFIQ bin Ahmad SAFARUDDIN, and my group members MOHAMAD SYAHRAIN bin ABDUL HALIM, Luqman Hakim bin BADRUL HISHAM, and Muhammad AKMAL bin ZAINOL. Okay, today I'm going to present about our assessment. Okay, so we got a question about the flow due to pressure. The question sounds like this: a conical tank is 6 meter high and has a top radius of 2 meter. Initially, it is full with water. A valve is open at the bottom of the cone, and water is pumped out at a rate proportional to the depth of water. After 1 minute, the depth has decreased to 3 meter, ignoring evaporation. Okay, from the question that this we already know that we are given the cone tank, which has the height 6 meter and the top radius 2 meter, and the rate proportional, water is pumped out at rate proportional to the depth of water. Okay, so we know that when the water is pumped out, the value will decrease, and it's given here after 1 minute the depth has decreased to 3 meter. So what we're gonna find out is, for the first question, we need to set up the equation for the water depth as a function of t, and we need to solve it. Okay, so B, we need to determine how long will it take to empty the tank. Okay, so we will look the solution.
Okay, so right here we have listed down some of the general steps to solve this kind of problem. Okay, so here the first step is to draw a picture to symbolize clearly about the problem. So here, this is exactly like in the question. So here we've drawn another easier figure for us to understand, to symbolize that this is the height of the conical tank, which is 6 meter, and this is the radius of the conical tank, which is 2 meter. So for the next step, we're going to identify the quantity that we're looking for. So this is it. We are going to find out about the rate, the decreasing rate of the water in the tank with the time taken. So here we have got ourselves an equation of dH over dt. So the next step is we have to identify the information given from the question. So as you can see before, we've got the values of radius of 2 meter and the height of 6 meter of the conical tank. Okay, so for the next step is we are going to identify the equation that relates the variables we have earlier. So we found out that we will have to use the formula to find out the volume of the cone. So this is the formula, V equal to pi over 3 times with R square times with H. So the next step is we don't want as of now we are having two variables, R and H. So for this step we are going to eliminate one of the variables to leave only one variable for us to easily solve the problem. So as you can see, we are having R and H. So R doesn't really relate with a problem, so we can just get rid of it. And how we're going to do that is we are going to do the simultaneous equation. So as you can see here, H is equal to 6 and R is equal to 2, and so we do the simultaneous equation process, and here we've got ourselves the value of R, which is equal to 1 over 3H. Then after we get the derivative value of the R, we are going to substitute the value into the general equation at first. Then here we do the process here, and then we got ourselves a new equation which doesn't have the value of r in it. So we have got ourselves v is equal to pi over 27 times with h cube. Okay, so here is the next step is we have to derive the formula because we going to find about the volume versus the time taken to empty the tank. So we have here dv over dt, and now we only have the formula of to find out the volume v times with the decreasing rate over time dh over dt. So here we're going to differentiate the formula of v with this code, which is v is equal to pi over 27 times with h cube. So to change this into the differential equation, we're going to differentiate this equation. So we go ourselves after we differentiated the equation, we're going to get ourselves 3 over 27 times with pi h square. So we've got the equation here, which is can be called as dv over dh. This is it, and then so this equation is actually the derivative formula. Dv over dt is actually equal to dv over dh times with dh over dt. So cancel out, it will come to this one. So this is it. We're just going to simplify the formula more and more. So here we've got the formula. Okay, so we're going to proceed with next step. So we just knew that dv over dt is actually symbolize that it is the decreasing rate of water. As we knew, we have also stated in our general step that when it is the rate of decreasing rate that we are finding, we have to make sure that we have the negative symbols to actually symbolize that it is the decreasing rate. So we have here negative h equal to dv over dt. So this is the formula we just got before for dv equal to dt. I'm sorry, dv over dt. So here is 1 over 9 h square pi h dt. So we just substitute the value of negative h we have here, put it here, negative h, and then we equate them. Negative h is equal to 1 over 9 h square pi dh over dt. Then we just solve it, and we've got ourselves here the value of dh over dt, which is negative 9 over h pi. So after that, we're going to find, actually we have to find the value of h. So we're going to integrate. We have here we have to integrate both sides of the equation. So here we integrate the negative 9 over h, the value of dh dt, and here we integrate the h. So after the integration, we've got here a new equation of h, but there is the c, the constant value here. So to solve the value of c, we don't want to have another constant here, so we want to solve it. We are going to substitute some values into the equation. So as we knew initially, when the time is 0, the height of the water is still 6. So we put the values into the equation. Here's the h, put it 6 here, negative 18, and the value of t here, we put it as 0. So we solve it, and finally we got the value c is equal to negative 18. So we put the value of C into the equation of H we just got just now. So here it is. We've actually solved the first problem, the question A problem. So here it is. This is the final answer for the A. That is H is equal to square root of negative 18t over pi plus 36. This is after we substitute the value of C. Okay, so we are going to proceed with the next question D. That is we need to determine how long will it take to empty the tank. So we knew that when the tank is empty, logically the height of the tank, height of the water inside the tank will be 0, but we don't know the time yet. So we already have the equation to find the height, which have the variable time inside. So we just can easily substitute the values of the height here into the equation to leave out the t, to find out the value of t. So after we solve them here, we got the value of t is actually equal to 2 pi. So then here we knew when H is equal to 0, which is already finished up the water in the tank, so the time will equal to 2 pi. Then we substituted the value of pi, which is 3.142, into the equation, and we've got ourselves here the value of t is equal to 6.283 minutes. Okay, so finally we're going to prove our solution for this question. So here we plotted a graph. So as we can see in the graph is about the depth of water in meter against the time to empty the tank in minutes. So this is the depth of water in meter. This is the time taken to empty the tank in minutes. So as we can see from the as had been stated in the questions before, when after 1 minute the valve has been opened, after 1 minute the height of the water will be 3 meters, and this one is when we had just calculated when the time is 0, the height of when the height is 0, the time taken for it to achieve this level of water in the tank is 6.283 minutes.